So here's a quick tour of RoboCommander. RoboCommander is an app for controlling robots. It can control any kind of robot that uses a REST or socket API. The current version is set up to control Jibo robots. So when you launch RoboCommander, you'll see this tab bar at the top. There's an App Info tab. And this is where you enter credentials for the various systems that allow you to control the robot. For Jibo, the most important are your client ID and your client secret, which you would get from the Jibo development team. Now, some of the skill examples can take advantage of Cloud NLU, in particular Lewis and Dialogflow NLU. So when it comes to experimenting with those aspects of RoboCommander, then you can enter in your credentials here. RoboCommander also includes an example of how to integrate a Neo4j graph database. So if you're going to work with the Neo4j example, then you would enter your Neo4j database credentials here. You only have to do this once. Once you've put your credential information in, make sure you hit the Save Config button so it remembers it, so you don't have to type it all over again. Then we can put that panel away. The Robots panel allows you to configure any number of robots. RoboCommander can control multiple robots simultaneously, or robots can be targeted individually to respond to specific commands. You can add a robot and then fill out the robot-specific information in the Robot Info modal dialog. When the robot-specific information is configured, you can connect to the robot by clicking on the appropriate button. When the robot's connected, you can either put this panel away or drag it somewhere so you can keep an eye on it. The next panel is the Commands panel. The Commands panel shows which robots are connected and which are targeted. When the robot button is a solid blue, that means it's targeted. That means if you click on a command, it will get sent to that robot. For example, let's send a TTS command to Jibo.
Hello world.
We can examine that command by putting the command panel in edit mode. Then when we click on the button, we'll get the command information. So this is a command with the helpful name TTS hello. It's a TTS type command, and this is the payload data. The next panel is the WAS graph panel. The WAS graph is a powerful way to set up custom interfaces for controlling the robot. This example graph has a number of buttons that are mapped to specific commands, like look left, look right, look center, say hello,
Hello world.
and an animation reset. WASGraph can also be used to simulate dialog trees. The auto-scroll feature, when it's turned on, will move from one node to the next based on the way that they're linked up.
So, do you already have an account with us?
No.
Okay, would you like to open an account today?
Yes, that would be great.
Great. To get started, please tell me your mobile number.
Okay, here you go.
Okay, now please show me the code I just texted you.
WASGraphs can also incorporate simple scripting. In this example, when Jibo hears his wake word and a command, the ASR gets sent to Lewis NLU, and if that matches an intent, the intent is returned and sent back to the WASGraph. Because of the launch node, that intent will then get examined, and if there's a link coming out of the launch node that matches the intent, then the next node will get executed. So in this case, if Jibo hears the launch it's me intent, then he'll ask this question. This question has a dynamically evaluated prompt that uses a variable. That variable is defined in a script. Scripts look like this. They can be any— the script name is indicated in the metadata for the node. In this case, the getPlayer script is specified. So getPlayer checks to see if the variable's been set yet. If it's not, it creates one. And then it checks to see if the user variable is defined in the memory space of the script. If it is, then the player's name will get set to that user variable. The user variable is one of the entities that comes back from the launch it's me Lewis intent. So when an intent is recognized, the entities associated with that intent are automatically added to the memory space for the script for this particular robot. That memory space is used as a VM sandbox in which the script runs. So in this case, the entity user is going to come back with the launch it's me intent. It's going to be Andrew because that's what I'm going to tell him I am. And then this prompt will get evaluated. Let's try it. Hey Jibo. It's me, Andrew.
Hi Andrew. Do you want to play a game?
Yes, I would.
Okay, let's get started Andrew. You are at the entrance to a mysterious valley. Will you continue or quit?
Some good acting there. Let's continue.
Good choice. Let's continue.
So if we take a look at the init game script, which ran when the init node ran, we'll see that because it wasn't initialized, the game was then initialized. The game setting, you are at the entrance to a mysterious valley, was defined. And the next prompt was defined. Will you continue or quit? And then those variables were evaluated in the ask node's prompt. And then the game command intent from Lewis was recognized. And so the good node executed, and its dynamic prompt was evaluated using the game command entity that came back from the Lewis request, which was, let's continue. So just one more example, we'll take a look at the launch game inventory, which is going to, if that intent is recognized, then it will dynamically evaluate this prompt here. Notice it'll also run the init game script, but because that's been initialized, it won't actually execute again. Hey Jibo, check my game inventory.
Okay Andrew, I checked and you don't have anything yet.
Alright, well we better get going. We'll take one closer look at the state, memory state that's associated with this robot for the execution of the scripts we just went through. This is robot Jade. So this is what the memory space looks like that's sandboxed for the VM evaluations of these JavaScripts. So you'll see that the variable user is currently, because of the last Lewis response, undefined, or it's set to the default someone. But earlier it got set to Andrew, and so that got remembered in the player name variable. And then when the init node ran for the first time, the game setting was defined and the game prompt was defined. And then when the game command came back from Lewis, the game command entity was set to continue. So this is the memory script, or the memory context right now, in which these scripts are running. Over time, this context will grow and change. This allows for some pretty rapid prototyping with a little bit of JavaScript and an easy-to-use graph-based layout.